Good evening, students. Today's session we are going to learn about what are the characteristics of process. Okay, so the three important characteristics of process that represent the system behavior are process gain, process time constant, and dead time. Okay, so when you want to study the characteristics of particular process, first you have to excite the process with the input. Okay, so here for our understanding, let us take the input as a step input. Okay, so excite the process with the step input and collect the step response. Okay, so from the step response you can study the behavior of the system by with the help of the three parameters. Okay, so one is called process gain, second one is a process time constant, and third is a dead time. Okay, so if you could see this response, this the bottom one is the input and the top one is the output. Okay, so the input is a step input and the respective output is a step output. Okay, so if you closely monitor this you can see that the gain process gain. Okay, so that is based on the amplitude. Okay, amplitude of the output to the amplitude of the input. Okay, and remaining two components are time constant and dead time, so that we'll be exploring now. Okay, so this two components is going to capture the dynamics of system. Okay, so first one is nothing but the steady state. Okay, so steady state is nothing but it is going to represent the process gain is always notated as K. Okay, capital K, and it is defined as a ratio of the change in output to change in input. Okay, and it is nothing but sensitivity. Okay, so gain if positive or negative, it specifies the direction in which the input and output variable changes. Okay, and it is very clear that as it is a steady state characteristics of process, it is very clear that it does not specify the dynamic of the process. Okay, coming to the next two characteristics of process, another one is a process time constant and process delay time or dead time. Okay, so process time constant is nothing but it tells how fast the process respond to the change in the input. Okay, so this term directly relates to the dynamic of process, and the speed of the response of the process and time constant are inversely related. Okay, so in the sense, if there is a process is faster, means the time constant will be lesser because they are inversely related. Okay, if you look into this response, okay, so this time constant is actually the time taken by the response of system to reach 60% of final steady value. Okay, so if you could look into this response, uh, at 60%, what is the respective time? That is called the time constant. And the last one is nothing but the process dead time. Process dead time is nothing but the finite amount of time that is between the change in the input variable when the output starts to respond, the time taken by the response. Okay, so the system takes some time to respond to the respective input. That time is called as a dead time. Okay, dead time means from the word itself it is very clear that dead is nothing but it takes some time to respond to the input. Even if there is a change in the input, there won't be a change in the output. Okay, and if you see this K and TD depends on the physical parameters of the process such as size and calibration. Okay, thank you, students.